Hello everybody and welcome back. In this video we are going to look at how to assign E and Z configuration for alkenes. Now normally we use cis and trans. For instance, for these two alkenes here, this should have hydrogen, this carbon here should have hydrogen, and this one too should have hydrogen. Here too we should have hydrogen, and here we should have hydrogen. Now when you look at these two carbon participating in the double bond, this first one and the second one, and you look at the two things that are attached to it, you look at the other ones too, right? You see that they have two things in common, hydrogen and hydrogen, or this ethyl group and the one here too. So we now check these two groups that are in common to both carbon atom participating in the double bond. If those two groups are opposite, at opposite side, we call that as trans. And when they are at the same side, like this and this, or these two hydrogen, when they are at the same side, we call that as cis. Now, problem arises when we have compounds that, for instance, this kind of compounds, say for instance, we have this, and we're having bromine here, okay, and we have double bond here, and we have let's say we have Cl here too, and we're having hydrogen, and we're having methyl. Now compound like this, how do we name it? Do we call it cis or we call it trans? If you look at this carbon, the two carbon that are participating in the double bond, the first one and the second one, they do not have anything in common. This is having chlorine and hydrogen, and this one is having methyl and bromine. So nothing is common between these two carbon atoms. So what we use in this case is the E and Z configuration. Okay, E and Z configuration. You might be asked, the E means entgegen. And this Z means zusammen. So if you want to use E and Z configuration, it's similar to the way we used to do for RNS configuration, in that you have to find, assign priority for the two things that are attached to those two carbon. For this first carbon, you look at those two things that are attached to it and you prioritize them. You give them priority. You do for this, you do for this one too. So say for instance, we're having, generally, if you have those two carbon that are participating and you have A here, you have B here, you have C here, you have D here. Let me use another one like E, because you're having C here already. If at the end you find the priority and this one over here is having higher priority than this one, and when you find for this one is having higher priority than this one, they are not necessarily the same actually. But when you find their priority, this is having higher priority than this, and this side to this one is also having higher priority than this. If the higher priority atoms or group of atoms are at the same side, that will be Z configuration. Okay, but let's say for instance this is 1 and this is having, maybe this is 2, and the higher priority is A. The higher priority for this carbon is A, and for the other one it is A. So they are at opposite side. In this case, it won't be Z again, it will be E. So that's just the difference between the E and Z configuration and cis and trans. Remember, cis and trans is between the same group, but here they are not necessarily the same. Just give them priority, and if the two priority group are opposite to each other, that will be E, and if they are the same side, okay, like the previous one, that will be Z configuration. So let's try that for this alkane over here. If you prioritize these two atoms that are bonded to this carbon here, this one we have 1, and this one is just carbon having 3 hydrogen. So we don't have concern with this. It is this carbon that is directly attached to it that we have to prioritize. So this one will be 2 and this one will be 1. For this one will be 1 and this one will be 2. Now the two priority atoms are at the same side. So it means that this one will be Z configuration. Okay, if you are confused that is it Z that is the same configuration, the same side, or E that is the same side, you can use this mnemonic Z same side. Okay, so which means that Z means same side. So you can use the Z same side. That's normally what people use to remember that. Okay, so let's say we have another one here. For instance, this one that is A. Let us try and prioritize it. Let us try and name it. So let us try and assign E and Z for that. So these are the two carbon participating in the double bond. If you rank them, this one is carbon and this one is chlorine. So definitely this one will have higher priority and this one will have the second one. But these two guys that are attached to this carbon here, they are both carbon. So which one are we going to give priority? So this is having two hydrogen attached, two hydrogen and one carbon attached to it. But this one is having just one hydrogen, okay, and two carbon attached to it. So definitely this one will take priority than, so this one will be the higher priority like that, and this one will be the lower priority. Okay, so let me just try and remove everything for us to see it clearly. So this is going to have higher priority like that, 1, and this is going to have 2. So, and this is going to have 1 and this is going to have 2. So since the two higher priority groups are at opposite sides, so that's going to be E. Okay, don't forget Z same side. So Z is for same side. Now let's look at these 4 practice questions too. The 10th practice question that is taken from a particular website, chemistrysteps.com. So determine if each of the following alkenes has an E or Z configuration. So let's start from here. So if you look at this is having bromine and fluorine. So bromine will definitely have the highest higher one, and this one is going to have 2. So chlorine is 1 and this is going to be 2 like that, higher priority. So higher priority are the same side, so that will be Z for this one. For this, now this is the parent alkene we are looking at, not this, because this is doubly bonded to oxygen. So we are looking for carbon-carbon double bond. Okay, so I have to put the hydrogen here for you to see it clearly. So this is definitely going to have 1, the carbon, and this is going to have 2 because it's hydrogen. Now these two guys, they are both carbon. Okay, so you have to check further, and these two carbon, they are having 2 hydrogen attached to them, one here. The same thing for this, and they are also bonded to the same carbon. Okay, so now which one is going to take priority? So we're still going to check further. Okay, so we're still going to check further. So this carbon is doubly bonded to oxygen, this one is doubly bonded to oxygen, and this one is, so which means that these two guys are actually the same. Okay, these two guys are actually the same. So in this case, what are we going to do? So the simple answer to this question is that E and Z is not applied to this because they are having the same group. So you can't apply this E and Z configuration stuff to this kind of compounds. Now let's look at this. So we have hydrogen here, we have hydrogen here too. So if you want to assign, definitely this is going to be 1 because carbon, this is going to be 2, this is going to be 2, and this is going to be 1 like that. Sorry, this should be 1, mistake. So this should be 1 and this should be 2 because that's hydrogen. Okay, and this hydrogen 2 will be 2 and this one will be 1. So when you look at them, the higher priority group are at opposite sides, so that's going to be E. Now for this, if you look at that, so this is having hydrogen, so it's going to be 2 and this is going to be 1. So when you look at this carbon is attached because this is a carbon and this one too is a carbon. Now let's break the tie. This carbon is attached to 2 hydrogen and 1 carbon, and this one is attached to 2 oxygen and 1 carbon. So definitely this one is going to take the first, second. So the higher priority group are at opposite sides, so that one too will be E. If you look at this should have hydrogen here, so this definitely will take the higher priority, second one. So when you look at this, it is bonded to 2 carbon. Okay, and each of those carbon 2 are having 2 hydrogen attached to them. So but if you look at the next, it's like they are the same thing. So if you look at the next carbon they still attached to, this is having 3 hydrogen and this one is having just 2 and 1 carbon. So this one will take the higher priority, and this one will be the second, like that. Opposite side, so that is E. For this you have hydrogen here, so this will be 1 and this will be 2, right? Carbon, hydrogen. This one, they are the same, okay, bonded to the same thing, 2 hydrogen, 1 carbon, 1 carbon. But this carbon is having another 1 carbon, and this one is having just 3 hydrogen. So this one will be the first, second. So higher priority group are the same side, so that will be Z. So if you check for this you have hydrogen, okay. Now this one will be definitely carbon, right? So that will be 1. This one will be 2. For this, it will be chlorine, carbon. So that will be 1, 2, right? This one is a carbon itself. So these are the higher priority group at the same side. So that will be Z. If you check for this, okay, this one is having O and this one is having O2. Now, which one will be higher priority? This O is actually attached to H and this one is attached to carbon, okay? So that is having 3 hydrogen. So if you consider it, these 2 carbon are having 2 hydrogen, still bonded to the same oxygen. So you still now check this oxygen further. So this one is bonded to carbon, this one is bonded to hydrogen. So that will be what? 1, 2. Now when you check for this, carbon, carbon. But this carbon is bonded to 1 hydrogen, 2 carbon. This one too is bonded to 2 carbon, 1 hydrogen. Okay, now let's check those 2 carbon that they are bonded to. These ones are bonded to carbon, carbon. This one are bonded to 3 hydrogen. So this one will take priority. Sorry, this one will take priority. This carbon here will take priority, and this one will be the second one. So higher priority go at opposite side, so that will be E. Then for this, if you look at that, so these ones, they are actually the same thing too. Okay, this carbon, if you look at them, they are bonded to the same thing and still bonded to the same thing. So you can't use E and Z for them. They are actually the same. For this, so this one carbon, this one to carbon, right? But this carbon is bonded to 2 hydrogen. This one is bonded to just 1 hydrogen and 2 carbon. So this one is just bonded to 2 hydrogen and 1 carbon. So this one will take priority. So for this, carbon, carbon. But this carbon is bonded to sulfur and this one is bonded to oxygen and fluorine. Because sulfur is having higher atomic number, so this one will take priority 2. So 1, 1, higher priority at opposite side, so that's going to be E configuration, like that. So that's how you do for them. So please make sure you like this video. So you just have to check. So when they have tie, you still have to check further. So you break the tie at the particular point of difference. So that's going to be the end for this video. Thanks for watching, and I do really appreciate you. Please make sure you like this video, subscribe to this channel, and give us your beautiful comments, and make sure you share to your friends as well. I wish you the very best in your upcoming examination. Thanks for watching.